to this system. And it's just where the lines intersect. So we're looking at right there. So that is the point. So you can either say it's the answer, the point negative 3, 1. Or you could put, x equals negative 3 and y equals 1. Either one of those is an acceptable answer. I don't know why this isn't working. Let's go to a different one. And yes, there'll be times where you have to graph it, but I'm not really going to look for answers because it all depends on how well you graphed it and how specific you graphed it. So this one says solve by graphing 2x minus y equals negative 8. X equals 2y equals 6. There's a few ways you can graph it. You can replace your x values with zeros. If your x value is 0, you're looking for your y-intercepts. You can replace your x values with 0 and get your y-intercept. And then you can replace your y's with 0 and get your x-intercepts. I usually just put it into slope-intercept form. It's the most basic one. It's probably the first one you learned with graphing. So let's just go back to it. So we just have to write these in slope-intercept form. Slope-intercept form is y equals mx plus b, but you don't have to remember the mx plus b. It's just y equals something. Get y by itself and positive, and you have it in slope-intercept form. So we have 2x minus y equals 8. Let's first move the x's to the other side. So that'll give me negative y equals negative 2x minus 8. It can't be negative y. It has to be positive, so I multiply both sides by a negative 1. And that becomes y equals, change that negative sign to a positive, 2x plus 8. That is now in slope-intercept form, where 2 is my slope. If you have to write some notes about slope, awesome, do it. I'll go over it. Slope is change in y over change in x. Or more affectionately, rise over run, which means you need a fraction. Well, since it's 2, I'm looking at it as being 2 over 1. It rises 2 and goes right 1.
That's what that means.
That is what that means.
Changing y over x?
Yeah, change in y over change in x. Maybe I'll come up with a blank slide here.
Never understood the whole rise, run thing.
So slope, there's two ways to look at it. You can look at it, and this just means change in y over change in x. That was supposed to be an x. Delta just stands for change, which is just rise over run. And how I always do it is I either go up or down, and I always go right. All right, when I'm looking at it. So if my rise is 2 over 1, I'm going to go up 2, right 1 unit. Let's go back to this. So this one, my slope is 2, and that 8 is my y-intercept. So as soon as it's in slope-intercept form, I'm just going to look at this number that's hanging by itself, go on my y-axis, and plot a point at 8. So we are plotting y equals 2x. We're going to put a point at 8. My slope is 2, which is 2 over 1, which means it rises 2 and goes right 1. Here's a problem with the graph. If I go up 2, I'm in la-la land. We can approximate it. Absolutely, we can approximate it. An easier way to do it is rather than going up 2, right 1, I'm going to flip everything. I'm going to go down 2 and left 1. And if you're not sure if that's doable, what I'm going to tell you to do is, so I'm going to go down left 1. I'm going to make sure my slope is still 2. So to go from here to here, I would go up 2 and right 1. So my slope here is 2 over 1. Everything works okay. So rather than going up to right 1, I'm going to go down to left 1. And I'm going to do that again. I usually do at least 3 of them down to. It just makes doing your line a little easier. So now I'm going to connect those 3 points as best I can. And that right there is my y equals a 2x plus 8. So once again, slope-intercept form, the most important part is that number that's dangling off. That goes on our y-axis. And our slope is rise over run, or change in y over change in x. All right, let's go do the same thing for the next line. So once again, I'm putting slope-intercept form, which means I'm going to move all the x's to one side. So I'll have 2y equals subtract x from both sides. And we have plus 6. I need to divide both sides by 2 to get y by itself. We're going to have y equals negative 1/2 x plus 3. I know more traditionally you probably would have seen it as negative x over 2, but I always bring that fraction out front so I know exactly what my slope is. So now I see I have that positive 3. So that tells me my y-intercept is at 3. Let me do this one in red. So we're going to be at 3. And my slope is negative 1 over 2. I always put the negative sign on top to tell myself to either go up or down. That tells me to go down 1 and right 2. So if we go down 1 and right 2, I'm going to be at the point 2, 2. Once again, you can do everything in reverse. If I go down 1 and right 2, I can also go up 1 and left 2. And we can see where these two things intersect. And that is at, what color do we got? Let's use purple. It is at the point negative 2, 4, or you can write x equals negative 2, y equals 4. Both are completely acceptable answers for me unless I say what is the point. Then you have to give me a point. But if I say the solution, you can either give me a point or the x and y values. Questions on graphing, because this was a crash course in graphing. Yes?
Are we going to lose points if we don't label which line is which equation?
No, in fact, I didn't, did I?
You did
I did the top one. I didn't even label the bottom one. Let's go ahead and do that. But no, I would not take off points for that.
Okay,
So we don't have to write the equation?
No. It's more or less for notes purposes, so you know which line you graphed. If you're struggling with graphing these, you might want to have them labeled so when you go back, you know which ones were which. Once again, any questions on graphing? This was a super quick crash course. I do expect you to be able to graph, though, because these are just lines. Okay. Least used. Don't like it that much just because it's not accurate. I can't give you decimals. And it takes up a whole bunch of time when it's much easier to do things algebraically. So, algebraically, elimination. Elimination is one of my favorite ones. A lot of times I'll just force things into elimination because I can picture it in my head and I can eliminate stuff in my head, versus substitution is a lot harder to do in your head because you're moving big chunks of data around. Elimination. The key to elimination is you need to create, or notice, a zero pair. And all a zero pair is two things when you put together equal zero, right? Crazy. And what zero? We do have the y's. In this one, we have our y's creating a zero pair. When I put these two things together, they just equal 0. So if I already have a zero pair, I'm going to go right into elimination, which means I'm going to add the two equations together. So I'm going to do 3x plus 2x gives me 5x. Negative y plus y, I don't normally write this, but just for the sake of notes, I'll say that equals 0. Equals 9 plus 1 equals 10. So that gives me 5x plus 0 equals 10. Simplifying that, I get x equals the big old deuce. You are not done, though. You need to figure out what y is. to find y, you just plug in an x value to either one of the two equations on top. I'm just going to go ahead and pick, I guess I'll pick the top one. So we have 3x minus y equals 9. Plug that 2 in for that x. And we're going to have 3 times 2 is 6 minus y equals 9. Subtract 6 from both sides. We're going to have negative y equals 3. So y actually equals negative 3. You can be done now, or you can write it as the point to negative 3. I don't care about how you give me the answer. They're both fine. However, what you should do, because if you're anything like me, you probably make dumb mistakes on easy problems, because you kind of just rifle through them, and negatives and stuff get mixed up. You should, at the very least, mentally check to make sure these numbers work. Or you can use your calculator to make sure these numbers work. So you're just going to replace your x and y values up here. I'm going to actually do it off to the side. I'm going to say this is where I'm going to test to make sure it's correct. I'll test the first one. The first one says 3x minus y should equal 9. So let's plug in our values. 3 times, I said my x is 2. So 3 times 2 minus a negative 3 equals, 3 times 2 is 6, minus a negative 3 is going to equal 9. That one works out. For our next one, we have 2 times our x value is 2, plus negative 3. 2 times 2 is 4, minus 3 equals 1. It was supposed to equal 1. They do work out. It's not hard to check these in your head, or at the very least plug in your calculator just to double check. It's going to save you that, when you take a test and it's just like, why'd I lose that point? It's just because you didn't take the time to check it. All right, our next one does not have a zero pair, so you have to create a zero pair. One thing you might want to look for is ones that are already a negative and positive, because then you don't have to switch it. There aren't any pairs that are negative and positive, so it really doesn't matter which one I pick. I'm just going to convert these x values to a zero pair. So I'm going to go ahead and multiply the top one by negative 3. And I'm going to multiply the bottom one by 2. If I multiply everything by negative 3, I'm going to get negative 3 times 2 is negative 6x. Negative 3 times 3 is going to be a positive 9y. Equals a negative 3 times a negative 2 is going to equal a positive 6. Several of you out here are going to forget to multiply this. It's just going to happen. That's why I always put a negative 3 and I put big parentheses around it to tell myself to do this. And if I keep making mistakes, I'll even put arrows going to everything. Don't forget about multiplying by what's on the other side of the equal sign. Then we're multiplying by 2. That'll give me 6x. 2 times negative 2 is negative 4y. And finally, we have 2 times 12, which is 24. I created a zero pair with this negative 6 and 6x. 9y minus 4y is 5y equals 30. Oh, that's nice, because then we just have y equals 6. And then we plug it into one of those equations. I'll just pick the bottom one just for the fun of it. So we had 3x minus 2y equals 12. I'll take this and plug it in for that y. And we'll have 3x minus 2 times 6 is 12 equals 12. Here's where silly mistakes happen. A lot of times this gets turned to 0. Just because in your head you see negative 12 and 12. It equals 0. Remember, you're adding 12 to both sides, so you should have 3x equals 24, so x equals 8. You're done there, or you can write that, the point 8. 6, I don't care. I just leave it as the x equals and the y equals. It's just why add another step to it. Make sure you circle your answers, especially on a test, so I know what you know and I know that we both know what the answer is. I don't like searching for answers. That's where you lose points.
That bad habit of accidentally picking the wrong one.
I do have a bad habit of accidentally picking the wrong one if I don't know which one's your answer. The last thing, substitution. Substitution relies on the fact that you need to solve for one of the variables. Be nice to yourself and pick the easier of the variables to solve. I picked the one that looks the loneliest. If there isn't a lonely one, then you just gotta kind of pick one. Y looks like the loneliest because the only thing attached to it is a negative sign. I just need to make that positive, and he'll be all by himself. So I'm going to pick the one that doesn't have a coefficient in front of it, as best I can. So I'm going to pick that one. Any one of them would work, and you get the same answer. Just make it easy on yourself. So I'm going to isolate y by itself. So the first thing I need to do is move those x's to their side. So I'll have negative y equals negative 3x plus 6. I don't want a negative y. I want it all by itself. So we're going to multiply both sides by a negative 1, which will give me y equals a positive 3x minus 6. I isolated y, and I said I can either write y or I can write 3x minus 6 wherever I want to. So we are going to replace this y here with that 3x minus 6 because they're both equivalent to each other, so it's okay to replace it. Ergo, substitution. So that's going to give me 6x plus 5 times, so let's put it in red so we know we're replacing something. That would be 3x minus 6 equals a negative 23. Let's rifle through this. We're going to have 6x plus 5 times 3 is 15x minus 5 times 6, which is 30, equals negative 23. 6x plus 15x is 21x's, equals, add 30 to both sides, I'm going to have 7, which is going to give me x equals 7 over 21, which simplifies down to 1 over 3. A lot of times I'll just circle that whole thing because they're all equivalent to each other. Or you can rewrite it as just x equals 1/3, your choice. Now I know x equals 1/3, I just need to find y. There's multiple places I can plug that in. I can plug that into the 3x minus y equals 6. I can plug that, plugging the x in. I could plug that x in for the 6x plus 5y equals negative 23. But I'm going to make my life a lot easier on myself. We already know y equals 3x minus 6. So the easiest thing to do is just take this value and plug it in for that x. So that's going to give me y equals 3 times 1/3 minus 6. Y is going to equal 1 minus 6. Y equals, that just says y minus 5. Y equals a negative 5. Questions, comments, concerns? Find one of these to like and love and use it. All right, it gets a bit complicated if you try to do every one on every single problem. Yes?
Are we ever going to be asked to do one specific method?
I don't think so. I think I'll just say, without matrices, solve this problem using either graphing, especially if I don't give you a graph and you have to do everything by hand, substitution, elimination. I could put this on the test, though. I remember last year I did, and I got a whole bunch of people to get stuff wrong. I just put this graph on and said, what's the solution? In fact, what if I gave you this graph and they never intersected? Ergo, they were parallel. How many solutions do they have?
No solutions.
No solutions. What if they are on top of each other?
Infinite.
Infinite solutions, all solutions. So you should know, if I give you a graph, what I'm looking for is the answer. Yeah?
Like, just having the equation without graphing, could you, like, plug numbers in to, like, figure out whether they're consistent, or...
I think that's the guess and check.
Is
So
it guessing?
guess and check. I don't ever use guess and check, but you could. Oh, like you plug in one x value and see if it works for the next one, and you do another one?
Is that how you, like, check it, or...
whether this is correct?
Whether like you know like the number of solutions, like how do you know whether it has like doing the math, not graphing, just solving the equation.
Oh, I'll show you.
Okay.
Yep. So she's already down to this section here, I think. Or you were doing it in your head already. You knew where we were going with it. Yeah. So we have to know these terms. We have to know consistent means one solution. We need to know inconsistent means no solutions. If consistent has at least one solution, we have two versions of that. It has exactly one solution. Or we have dependent, which is infinitely many solutions. Let's go over these. If there's exactly one solution, it means it's independent, which means it's consistent, independent, exactly one solution. If I was to graph these, independent graphs will intersect at one point. So the two from the start of this lesson would be intersecting lines, so they would be exactly one solution, so they would be independent. The two in the beginning were independent because they're intersecting lines. If I was using elimination or substitution, I know it's independent if I get one x value and one y value, just like we did in the problems before. I'll say x equals 3 or y equals 4. Dependent is infinitely many solutions. If I was to give you a graph and said, is this dependent, you would know they're dependent if there were overlapping lines. There were two lines that were on top of each other. They would be dependent. If you were using elimination or substitution, you would know it's dependent because while solving it, your variables would disappear. All right, your x's and y's would both cancel out. And you'd be left with numbers on either side. If what you're left with is true, like this statement here, 3 equals 3, if it comes out as being true, it is dependent. If your variables drop out, you have no more x's or y's while solving it, and the statement is false, like it says below, like 5 equals 9, then it will be no solutions, it will be inconsistent. You will know it's inconsistent by graphing if it's parallel lines. These are the two weird cases. Right here, I'm going to go ahead and circle them. These are those, I think I did something wrong while solving it because your variables just disappear. Like I said, you'll have no x's, you'll have no y's while you solve it. In which case, you're just going to ask yourself, is it a true statement at the end, or is it false? True means infinite solutions, false means no solutions. Did I answer your question? Okay, good. All right, any questions on any one of those situations? Be on the lookout for, on the homework I do say, tell me whether it's inconsistent, consistent, independent, dependent. All right, the other thing attached to this section is word problems. This is probably the easiest word problem that I can have. Yours for homework's a little more difficult. But this is just basically, while on stakeout protecting Earth from the scum of the universe, Agent Mulder observed 5 men in black enter a coffee shop and get 3 donuts and 5 coffees for $3.30. Next, 3 aliens in disguise enter the shop and buy 4 donuts and 3 coffees for $2.75. How much does a coffee and a donut cost? First of all, awesome. It's got both ways to write donut. Both are correct.
I like the first one better.
I like this one better because
Yeah,
I'm a sloppy man when it comes to writing. So it's just, yeah.
I feel.
Well, typing it, I hated writing the full out way, so that's why I snuck this one in there.
I feel like donut is like its own thing. Like it's not tied to anything, but like a dough nut, like the first one, is like
A nut made out of dough,
Yeah, it's
like
like
a peanut first.
yeah, it's like tied to baking and desserts. But then like that donut is like nope, it's its own thing.
It's his own thing. Okay. Anyway, we're gonna go ahead and solve this. Like I said, this is about as easy as it's gonna get, because it specifically says 3 donuts plus 5 coffees equals $3.30. Then right below it, it says 4 donuts and 3 coffees cost $2.75. Yeah.
Could we
add the prices together and then add all the products together and then figure it out that way? Or do we have to keep it separate?
You want to do some sort of elimination. I'm going to keep it separate when I write the equations. I'm just going to, for the sake of not writing donut and coffee over and over and over, I'm going to let D stand for donut. And you'll have no idea what I'm going to let stand for coffee. A squiggly mark. No, I'm just kidding. I'm going to put a C. It almost was. Or you can use X and Y. You can use whatever you want. A cow and a chicken. I don't care. All right. So the very first equation says that 3 donuts, let me highlight it. It says 3 donuts plus 5 coffees is $3.30. So we're going to write it down. 3 donuts, 3 D's plus 5 C's equals $3.30. Then right below it, it says that 4 donuts and 3 coffees cost $2.75.
Obviously, the coffees are more expensive than the donuts.
Oh, we'll see. We will see. Equals 2.75. Now I have a system of linear equations, which you have 3 perfectly valid methods. Don't graph it. But if you want to, you can. It's a decimal, so it's going to be very, very tough graph. I want you to solve this. I want you to solve it. Elimination is probably your easiest bet, but you can definitely use substitution. I'm going to go ahead and write down the answer to it. I'm not going to show you at all because I'm lazy. You know that.
That's cheap. Cheap.
Well, they're aliens. They get discounts.
But they're in disguise.
I got coffee equals 0.45 or 45 cents, and I got the donuts equaling 35
I want a donut
cents.
for 35 cents. Coffee?
45. The rest is homework.